Alrighty, welcome back, everybody. We are now onto the OSI model course, or I guess lesson. In this, we will be going over the fundamental networking framework that kind of moves all data across networks. So it's super important. It's a lot of information, but it's good information, and it will carry you through your entire career. Just like the other ones, there is a video hosted by TryHackMe. You guys are more than welcome to go and watch them run through it in like 20 minutes. So, going right into it, the OSI model. Let me go ahead and get rid of that. OSI model is the acronym for the Open Systems Interconnection Model. And you can think of it as a framework, okay? So, all network devices, when they're sending packets of data, the packet is following this framework in order to actually be interpreted and read correctly. Because all these different devices, whether it's video game systems, cellular phones, email, all these different ways of communicating, that that essentially needs to be translated in a universal language, and how that gets across is through this framework known as the OSI model. So again, the Open Systems Interconnection Model. All right, and in this model, there's several different layers. So 7654321, we have the application, presentation, session, transport, network, data, and physical. I've always known it like when I've studied for tests with this, it's was people don't need those stupid packets anyway because it's networking. Some people might say like sausage pizza or pasta, but people don't need those stupid packets anyway. That is a good thing to remember for that. And looking at the questions, there is a very useful term, which is this last sentence right here where it goes into it. It's called encapsulation. So the data is going to go through encapsulation at each one of these. All right. So let's go ahead and answer this. What does the OSI and OSI model stand for? Remember, it's Open Systems Interconnection. There we go. How many layers do we have? We have 7 layers. And what is a key term for when pieces of information get added to data? And that's that encapsulation. Alrighty. So we're now going to go through all of these layers, with layer 1 being the physical layer. So that's the easiest of layers of graphs. It is the physical components of the hardware that's used in networking. Alrighty. So this is the level, the layer in which electronic signals are used to transfer data using binary. So binary is the 1 and 0s. If you've ever seen the whole matrix background and stuff like that. All right, so we are talking about the physical layer. What is the name of this layer? It's physical. What is the name of the numbering system that's both the 1 and 0s? That's binary. And what is the name of the cables that are used to connect devices? So if we look right here, that looks like an RJ45 connector. And those are also, let's see, layman's terms, those are Ethernet cables. All right. So the physical layer deals with Ethernet cables. You know, the like, have you ever seen at the back of your NIC or maybe on a switch or something where there's the green light and the orange light and you see them power, going off and on? Well, that's traffic going across that layer. Next, we're going to go into layer 2, which is the data link layer. So this is talking about the physical addressing of transmission. So it receives a packet from the network layer, including the IP for the remote computer, and adds in the physical MAC address of the receiving endpoint. So inside every network-enabled computer is a network interface card, or a NIC. I know I just said that, and which comes with a unique MAC address to identify it. So we've already learned about MAC addresses. So this goes through basically what we already know. We know about MAC spoofing as well. And additionally, it's also job of the data link layer to present the data in a format suitable for transmission. So let's go ahead and answer these two questions. So what is the name of this layer? It's this big one right here. It says data link. And what is the name of the piece of hardware that all network devices come with? That's that NIC, okay? Which is a network interface card. Boom. Alrighty, we're zooming right through this. Next is layer 3, which is the network layer, which might sound kind of redundant if we're talking about all this networking stuff, but there is a layer in the OSI model known as the network layer. That's the third one, and that's where routing and reassembling of the data will take place. So, firstly, routing simply determines the most optimal path in which these chunks of data should be sent. So, while some protocols out there determine exactly what the optimal path that the data should take to reach the device, we should only know about their existence at this stage of entry. We're learning the foundations of networking. So data will travel amongst the most optimal path. All right. Apology for the noise if you guys can hear that. So some protocols that deal with that is OSPF, which is Open Shortest Path First, and Routing Information Protocol, which is RIP. The factors that decide which route is taken is decided by the following. So if we're talking, okay, we have which path is the shortest, which path is the most reliable, and which path has the faster physical connection. So what has the least amount of hops, what has the most reliable, so have packets been lost on this path before, and then which path has the faster connection, so are using, in this example, regular copper versus fiber, what speeds that it's actually operating on. And at this layer, everything is dealt with IP addresses, so it's all logical. And devices such as routers are capable of delivering packets using IP addresses known as layer 3 devices because they're capable of working at the third layer of the OSI model. So right in this diagram, we have two computers, and this computer is, let's say it's in San Francisco, this one's in Oakland, this one sends in, it's trying to send a message. Maybe it's an instant message, maybe it's an email, something like that. Just sending data over to computer B, and it's going to hit its router. It's now hopping on another network to hit that, and then another one to then hit the network that computer B is actually on. So these are public networks. So like if you think when you're trying to hit Google, your your house does not have a one-for-one connection to Google. Typically, I'm assuming most houses do not. If not, you might be living in a data center or something like that. But yeah. So that is kind of how layer 3 is explained. Network dealing with IP addresses. So what is the name of this layer? It's the network layer. Will packets take the most optimal route across the network? In layman's terms, yes, they will. What does the acronym OSPF stand for? Remember, it's Open Shortest Path First. So, Open Shortest Path First. And what does acronym RIP stand for? It's the Routing Information Protocol. So, Routing Information Protocol. And what type of addresses are dealt with at this layer? So, layer 3 deals with IP addresses. Now, if you remember our layer 2, the data link was with the MAC addresses. All right, so layer 2, MAC addresses, layer 3, IP addresses. Moving on to layer 4. All right, so we have transport, which is fairly important in this OSI model. Um, when you think of the transport layers, there's going to be two different protocols. There's TCP, which is known as the Transmission Control Protocol, and UDP. Alrighty, so we're gonna go into TCP first. All right, so TCP, Transmission Control Protocol. So I guess let me back up. All communication, just simplifying this, but all communication with data is gonna be one of these. Alrighty, so it's either TCP, where it gets to do error checking and it wants to make sure that all these packets, if it's sending thousands of packets, they're in the proper order that it was sent to. Um, there's good communication between both nodes or endpoints that are sending the data. So TCP has a lot of advantages, and they're listed here. So We have it guarantees the accuracy of the data. It's capable of synchronizing two devices to prevent each other from being flooded with data, and it performs a lot more processes for reliability. On the flip side, all that comes at a cost, okay? So the disadvantage is you need a reliable connection between the two devices. If one, like it says chunk of data, so if one chunk of data is not received, then the rest are not going to be usable because it's missing that one. Like it wants whatever data it's sending to be pristine condition for you, all right? And another disadvantage, a slow connection can bottleneck another device as the connection will be reserved on the receiving computer the whole time. And the main disadvantage of TCP, as I see it, is it's just significantly slower than UDP because all this additional work, making sure everything's proper and the transmission is good, it's making sure everything is nice in order. So, like in this diagram, we have a web server here in the computer. The web server is setting a picture of a cat. So, in the first packet, it's cat's head. The second packet, like his chest, and the third is the bottom here. And then you get it, and your cat's not out of order. All right, the head's not down here, and the tail's not up there. That type of deal. So, main use cases: TCP is used for file sharing, internet browsing, or sending an email. So and that is because we want these to be accurate and complete. Alrighty. UDP, on the other hand, user datagram protocol. Alrighty. So it's not nearly as advanced as TCP. Um, UDP really doesn't care if the packets get to their destination because it's just kind of going with it. Alrighty. And you might say, well, what's the point of that? Alrighty. Because why would I ever want, if you look at this diagram, a cat with only a head and a bottom because it's missing that? Like that just seems a little bit crazy. Why would you want that? Well, on the internet we use data in a lot of different ways. So if you're streaming a video, if you're in like a Teams call as well, you don't need every single frame of that video to be absolutely pristine in 4K or whatever. Services degrade, signals, get stronger, weaker, and I know we've been watching YouTube and it kind of downgrades itself to a lower quality and things are kind of blurry, and then once it comes back, then it's good to go. That's YouTube's algorithm kind of adjusting for it, but your video didn't stop the moment that service degraded and it was missing the packet. It didn't say, okay, you have to stop exactly at 1 minute because I don't have the next frame for 1 minute, 1 second. No, it kept going and it might jumped a little bit, might have skipped, if you're live streaming. But typically, as long as the session is still there, that those packets are still going. So if we look at high level TCP, you want it for file sharing, emails, things that you want accuracy in. All right. UDP, streaming stuff like that. Hey, as the packets hopefully get there, but it's not going to ruin everything if they don't. So the advantages of UDP though, because you might be thinking, why even use it? Well, so that things can actually still progress and get done. So advantage of UDP, it's much faster than TCP. UDP leaves the application layer to decide if there's any control over how quickly packets are sent. So that's why I was talking about like how YouTube might degrade or bump you up in terms of quality. And UDP does not reserve a continuous connection on device as TCP does. So the disadvantages is UDP doesn't care if the data is actually received, and it's quite flexible to software developers in the sense that, oh, okay, I see what's going. It's going off of that. And then finally, let's see. This means that an unstable connection result in a terrible experience for the user. Yep, it might. You might have a horrible connection, period. Um, but things happen. All right, like it's not as intensive. It does have its benefits, but that's a byproduct of it. So let's go ahead and answer these questions. So first, what is the name of this layer? And we're at the transport layer. What does TCP stand for? And that's that Transmission Control Protocol. UDP is the fun one. which is a user datagram protocol. All right, so user datagram protocol. And what protocol guarantees the accuracy data? So we have 5 questions here that are going to ask, do you use TCP or UDP? So if we want the accuracy of data, we're going to go with TCP. What protocol doesn't care if the data is received or not by the other device? That's going to be UDP. What protocol would an application such as an email client use? That's going to be TCP because it wants accuracy. You want your email to start with, dear this person, here's the body of your email, and maybe a signature line. You don't want it to go, dear this, one line, signature, rest of the body if it came through that way. All right, and which protocol would an application that downloads files use? That's going to be TCP as well. If you're downloading a video game, it wants to get all the gigs of data in a proper order, so when it extracts and the exe runs, it knows what it's looking at there. Let's see, and it's not missing any pieces. And which protocol would an application that streams video use? That's going to be that UDP, okay? So cool. That was layer 4, the transport layer. Moving on to layer 5, we are at session now. So the session layer, that's what we're going to be talking about. So once the data has been correctly translated or formatted from the presentation layer, the session layer will begin to create and maintain the connection to the other computer for which the data is destined. Let me go ahead and silence my phones because they are going off right now. Sorry about that. Alrighty. So when a connection is established, a session is created. So remember that. When connections get established, sessions are created. And while the connection is active, so is that session. All right. The session layer is also responsible for closing the connection if it hasn't been used in a while or if it's lost. Additionally, a session can contain checkpoints where if the data is lost, only the newest piece of data is required to be sent, so it saves bandwidth. So what is worthy of knowing is that sessions are unique, meaning that data cannot travel over different sessions, but in fact, only across each session instead. So not a lot to it, but it is proper vocabulary and it does have its own layer. All right. And what is the name of this layer? Is that session layer. And what is a technical term for when a connection is successfully established? All right. Don't know if they spelled successfully there, right or wrong. I don't know. That's gonna bug me. Anyway, it is also session. All right, because that's what you make. All right. Next up, the presentation layer. So that's level 6. So layer 6 of the OSI model is a layer in which the standardization starts to take place because software developers can develop software or any software such as an email client differently. The data still needs to be handled the same way no matter how the software works. So this layer acts as a translator for the data to and from the application layer, which is layer 7. The receiving computer will also understand data sent to a computer in one format, destined in another format. For example, when you send email, the other user may have another email client to you, but the contents of the email will still remain the same. And security features such as data encryption, so HTTPS, this all occurs at this layer 6 of the presentation layer. Alrighty. So you have all these different pieces of software. So if we just, they used email. You have Outlook, Gmail, Thunderbird, all the other open sources. I mean, Yahoo has email, Yahoo Mail, Proton Mail, all these different email clients. They're all dealing with email, okay? But they need to universally be able to acknowledge, okay, this is an email message. This is what the packet should be looking like. So let's go to the questions. What is the name of this layer? Layer 6 is known as the presentation layer. And what is the main purpose that this layer acts as? So it's going to be a translator, all right? So because it's translating all this different data to then present it to the application layer in a way that it will understand. So the application layer is layer 7, and it is the layer that you're probably most familiar with. And the familiarity is because the application layer is the layer in which protocols and rules are in place to determine how the user should interact with data sent or received. So everyday applications such as email clients, browsers, or file server browsing software such as FileZilla provide a friendly GUI, which is a graphical user interface. Again, a graphical user interface for users to interact with data sent or received. Other protocols include DNS, which is the domain name system, and that's how websites are translated into IP addresses. So Google.com has an IP address um, that computers honestly know they're absolutely fine. They can route traffic. So if your DNS is ever broken, if somebody ever says like, "Hey, your DNS is broken, so you can't get to Google.com," but if you know Google's IP address through a ping command, which we went through earlier, then you can just hit it off of like in your actual address bar. Just hit up the IP address. And here's just a picture of um, it looks like an FTP server, and it's hosting a couple different folders and whatever. So yeah, so there's your FTP, boom. So what is the name of this layer? It is the application layer. And what is the technical term that is given to the name of the software that user interacts with? So that's that GUI, which is the graphical user interface. Cool. And next we have a practical. So we have the OSI game, which is going to be fun. Um, it is about was it's a race, so you and your friends can race and see how fast that you guys go. It says, can you escape the OSI dungeon? Climb the levels in the correct order to escape the dungeon and reveal the flag. So let's see. TryHackMe OSI dungeon. Insert coin. I love this little aesthetic, but our hacker has been locked in the dungeon. Their only chance of freedom is by choosing the correct path based on the OSI model. Use your cursor keys to move left and right and the spacebar to enter the door. And I suppose you can kind of cheat right here and get a head start, but we are just going to go ahead and go with it. If we remember, people don't need those stupid packets anyway. So between physical and transport, I want physical. So people, uh, data link, don't need for the network. Transport, session, presentation, and application. All right, the 7 layers of the OSI model. Well done. You escaped the dungeon. It completed in 25.99 seconds. I think you guys can beat me. All right, so let me know if you guys beat me. And we have a little flag right there. So go ahead, grab the flag, hit submit. And then it says we will be continuing on learning with the packets and frames room. Not sure if that's the next one, but we'll see in the next video. Congratulations, everybody, for completing the OSI model. It is a foundational piece of network knowledge. It carries you not only through normal networking stuff, but it is very useful in the cyber world as well. So thank you all for doing this with me, and I'll see you in the next one. Thanks.